Okay, today, section 8.3. Yeah, we're in this chapter 8, and we've been doing some work with, I'm given something like 1 plus 2i, and we called that a complex number. And we looked at adding and multiplying and dividing and working with a bunch of complex numbers. And one of the things we also did was we took this guy, which, we call him rectangular form, thinking about the real and the imaginary. And we were able to put him on there. And then we were able to do some work with that. All of a sudden, I did X and Y, and we did R and theta. A quick review going from rectangular form to trig form. And trig form, as a part of a quickie review, was something that looked like R CIS theta. R CIS theta. In this case, I'm given 1 for my X value. I'm given 2 for my Y value. And I know I need to calculate R. R was the square root of X squared plus Y squared. R became square root of 5. Okay, the square root of X squared plus Y squared. We were happy with that. In order to calculate theta, and I have my triangle here where I came over 1 and went up 2, and here's my theta. I needed the tangent of y over x. So when is the tangent of theta equal 2? And then we did the whole theta equals the inverse tan of 2. Put that in the calculator, and we were able to find theta, which allowed us to write square root of 5 CIS, whatever that angle measure was. Okay. And that again became cosine of that theta plus square root of 5i sine of whatever that theta was. I don't have my calculator close by to do it, but that's what we did last class. We got into doing all of that, taking these complex numbers and putting them in something called trig form. Looking at them on a Cartesian coordinate system, put them in trig form. Now today what we're going to do is take advantage of knowing how to do this. So it's like we actually learned something, and we're going to apply it into probably something you don't think is exciting, but I think is kind of exciting. And I'm going to start by saying, all right, here's 2 complex numbers, a real part, imaginary part, and yada, yada, yada. And I'd like to get ready and multiply those. I want to multiply those. Okay, so I know by double distribute, 1 times both of these, I square root of 3 times both of these. So I'm going to get -2 square root of 3 plus 2i. Oh, minus 2i square root of 9. Well, that's nice. Plus 2i squared square root of 3. I hope I did that right. I usually have checkers that help me out. Minus 2i squared root of 9 and da 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 da. Going to do a little cleanup. -2 square root of 3 plus 2i. That becomes a 3 minus 6i. That becomes a -1 minus 2 square root of 3. Minus 2 bananas and minus 2 bananas is minus 4 bananas. 2 and -6, -4.
I have a question.
Yeah.
Where did the square go on the 2i squared times square root or square root of 3? Like the very last bit.
Like this one?
Yeah.
Okay. So the I squared becomes -1, which turns my positive to that, and I'm left with this. So now I have minus 2 bananas, and minus 2 bananas is minus 4 bananas.
Gotcha. Okay, thank you.
Yep, yep. Yep, yep. Okay, so now I want to look at another way to do this problem that's going to make things a little bit easier later. And what I'm going to ask you to do first is convert these rectangular forms into trig forms. The other word was polar form. So I'm going to come over here and start to do, I'm going to look at 1 plus I squared of 3. And I know that's going to be over here. And my x term is 1. There's my square root of 3. My second one was negative 2 square root of 3 plus 2i. And I know that guy has to be up in this quadrant because my x value is negative 2 square root of 3. My y value is 2. So I like to know where my locations are to make sure my angle measures are going to be in the right spot. All right, so this guy, my first R is going to equal,
A,
what does it equal?
A.
One more try.
I think A because square, negative 4 square plus negative 4.
Hang on, I want to find the hypotenuse. Now don't look up here. Don't look up here. We're past that. We're now down here. I'm looking at this triangle. This is 1 when I square it. This is 3 when I square it. That's 4. That's a 2. Oh, yeah, that is a 2. R equals the square root of x squared plus y squared. This one's R equals this squared plus this squared, and then I take the square root of it. No, oh boy. This squared is 12 plus 4. 12 plus 4, right? 4 times 3 is
16,
12.
4.
Yeah, this R equals 4. Okay, I'm getting ready to do this theta. The tangent of theta equals y over x, but I'm going to, I don't need to do the work because this triangle is familiar to me. My theta is, in fact, 60 degrees. That's my 30, 60, 90 triangle. And believe it or not, I know this theta. It's 150 degrees. Yeah, if I put the 4 in here, if I divided all those by 2, I'd have 2, 1, and the square root of 3. So that's 30, and that's 150. Huh. Got lucky. I did not have to use tangent of theta equals y over x. I could have. I just got lucky and recognized those. I know, right? Yeah. So the first one, Chow, go.
So can we convert to the radian like pi over 3 or something like that, or we keep the degree?
I work better with degrees.
So it doesn't matter if I convert to easy
It doesn't
to
matter. Nope. You are more than welcome to do that.
Oh, gotcha.
Okay, so now up here, I have my first one, 2 times the cosine of theta, which is 60 degrees, plus I sine of 60 degrees. My R is 2, my theta is that. So my first rectangular, my complex number written in trig form looks like this. My second one is with the 150. 4 cosine of 150. I'm gonna run out of room, plus I sine of 150. Agreed? So I took both of these numbers, both of these complex numbers, and I made them both trig form. All right, 2 times 4, right? I can pull that out. 2 times 4. Oh boy, I have the cosine of 60, I sine of 60, the cosine of 150, I sine of 150. So now I have the cosine of 60 plus I sine of 60 times sine of 150. Excuse me, that's cosine. I sine of 150. Whew. All I did was bring the 4 to the front, 2 times 4. Oh boy. I could try to multiply these. I could try to multiply them. Any ideas what we might want to do next?
Want to substitute the values of cosine 60 and sine 60 into like you could probably draw out the triangle for cosine 60 and find a reference angle.
Okay, that's possible. I like your thinking. What if I multiplied these? I don't want to, because I don't have a lot of room. That's a poor excuse. I'm going to multiply these. 2 times 4 is 8. Cosine of 60, I'm going to shortcut it. C of 6, I'll write it out. Cosine of 60, cosine of 150, plus cosine of 60 times I sine of 150, plus I sine of 60. Oh boy, I hope there's a point to this. Cosine of 150 plus I times I is I squared sine of 60 sine of 150. Hey, yeah, 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 yeah. 8 times. Check this.
Cosine of 210 degree.
No, I can't do that.
Why?
Where are you headed with that? Okay, go ahead. I'm gonna let you tell me how you got that.
Because you modify with the cosine 60 and cosine 150 degree. And I could write for the 8 cosine of 210 degree. That's right.
Just with these two? Not yet. Boy, my brain is.
Oh, I
Hang
can
on
see
one-
it.
Yeah, watch this. If I go cosine of 60, cosine of 150, okay, this becomes minus, because of that, sine of 60, cosine of 150. So I just took that last one and brought it up with the first one. And now I'm saying, wait a minute, I know what this is. I took the first one and the last one, and I got to that point, and I'm saying, I know what that is. Cosine of the first, cosine of the second, minus sine of the first, sine of the second. That's one of my ever popular identities. What you say? That's one of my identities. That goes all the way back to here. Cosine, cosine, minus sine, sine. That's the same as adding them together. So this now I can add together. This now becomes the cosine of 60 degrees plus 150 degrees. Because of this one and this one. Now, if I took, some of you go, oh boy. If I looked at this one and this one, they both have an I in it, right? If I pulled the I out,
Sorry, Professor.
I have cosine of the first, sine of the second, sine of the second, cosine of the first, and that is just my other property, and I get this. Okay, so the reds I put together, and it was the reverse of the cosine of the sum. The blues, once I pulled the I out, it was the sine of a sum. The sine of the sum was sine of the first, cosine of the second, plus sine of the second, cosine of the first. So there it is. So this now becomes 8 times cosine of 210 plus I sine of 210, which I can then figure out. Ooh, gonna have to run over here to the side. What's the cosine of 210? What's that? And when I multiply, I should get what's up there. So I'm going to say the cosine of 210, scrap paper, here it is. Cosine of 210, that's here. That's 30. 1 square root of 3, 2, negative and negative. So now I want the cosine, so now I have 8 times the cosine, oh, where are we? Here we go. The cosine, negative square root of 3 over 2. Plus I, the sine, negative 1 over 2. Multiply that by 8, I get negative 4 square root of 3 plus, that actually becomes a minus because of the negative, minus 4. I. And woohoo, we got the same answers above. Holy cow. I think the above way is a little bit shorter. Let's see what we did again. The first thing was I converted them, which I was doing last class. Come over here, I calculated 2 and theta for the first one, and I calculated r and theta for the second one. So when I wrote it out, and I didn't give myself much room, I had 2 CIS 60, 2 CIS 60 times 4 CIS 150. 2 CIS 60 times 4 CIS 150. I brought the 2 and the 4 together. Good. I had CIS 60, CIS 150. Wrote them out, foiled them, right? Double distributed. I was fortunate because I know what I'm doing, that I was able to say this guy and this guy, the reds, were the reverse of the cosine of a sum. Cosine of the first, cosine of the second, minus sine of the first, cosine of the second. That should have been a sine. Sorry about that. Those two together were my cosine. The 2 blues, after I pulled the I out, they were the result of my sine of a sum. Now I have 8 cosine of 210. I sine of 210. Yeah, these two did not make the cosine of 210 degrees. Nope, it didn't. I needed both of these to put together. Once I did that, I went to my 210, got the negative square root of 3 and negative 1/2, got the same answer. So let's see what a shortcut was. When I started up here, this guy, 2 CIS 60, CIS 150, turned out to be, 4 CIS 150, turned out to be 8 CIS 210. So we went through and just a little proof, which we didn't do much of in this class, that if I multiply 2 trig forms together, it's the same as multiplying their R's and adding their degrees. In other words, I get this product theorem. RCIS theta times RCIS theta equals R times CIS of the sum. Which means now, if I do it on this problem, you're going, hey, I know how to do this because this is what we just talked about. I want the product of this. So that's going to be 3 times 2, 6 CIS, their sum, 45 degrees plus 135 degrees, which is going to be 6 CIS, 180 degrees, 6 cosine of 180, plus 6I sine of 180. I'm going to go and do this one. 180 is to here. That's the point -1, 0, which means my cosine is -1. My sine is 0. This ends up equaling -6. -6. Oh. Oh. How about that? How's about that? Yeah, good. Okay. All right. Well, that was the product. That was the product. Let's take a look at divide. Let's make it a little cleaner, maybe kind of quicker. If I want, oh boy, if I was doing this regular as a complex number, I would multiply by the conjugate. Excellent, excellent. -2 square root of 3 minus 2i over -2 square root of 3 minus 2i. All I do is multiply by 1. Whew. Go ahead, take a minute on that one. See what you get. I'm going to do this slow. -2 square root of 3 minus 2i minus 2i squared of 9 4 square root of 9 plus 4i squared of 3 That's a mouthful there. That's a foreign language to some people. They look at that and go, what are you talking about? So far, so good? Hopefully you're all at least to this point or past me. Okay, good. -2 square root of 3 minus 2i. That becomes minus 6i. That becomes plus 2 square root of 3. I like that. -2 minus, and that becomes 3, which is 6. And that becomes a plus. That becomes 12. Oh, those two cancel. And that becomes plus 4. Yeah, I get that guy and that guy. They can't. Okay. Minus 8i over 16. Negative I over 2. Huh. How about that? That cleaned up pretty nice. Oh boy, convert the last example to trig form, then divide. Let's see. 1 plus I squared of 3. If I thought about it on a graph, it goes over 1 and up the square root of 3. So here's 1, here's square root of 3. That's kind of nice because again, this time my R is 2. And again, this is a theta that I know. It's 60 degrees. And my other number is -2 square root of 3 plus 2i. And that's going to be -2 square root of 3 and then up 2. This is a little bit like, yeah, this is like the last one. R is 4. And I think we had a theta of 150 degrees. So this is 2 CIS 60, 4 CIS 150. Same as last time. That's good. All right, so I want to divide. So now I have 2 CIS 60 over 4 CIS 150. Guess what's going to happen this time? Well, if I wrote these out and I wrote out, if I wrote these out, I'd have 2 times cosine of 60 degrees plus I sine of 60 degrees over 4 cosine of 150 degrees plus I sine of 150 degrees. And I said, okay, this time my R's, or National Talk Like a Pirate, R's are going to be divided. And oh boy, I would have to multiply top and bottom by the conjugate because this I is a square root. And I'd have so much work to do. I'd be going, oh my goodness, this is ridiculous. But in turn, I would find out that this becomes 1/2 CIS of 60 minus 150 degrees. Yeah, that's what it would become. So this time I divide the R's and I subtract the thetas. Last time I multiplied the R's and I added the thetas. 1/2, I want to finish this bad boy. 1/2 CIS of negative 120 degrees. Negative 120 degrees is also positive. Instead of going around this way, 120, I'd go this way. What's 360 minus 120?
240.
240. Now I'm gonna have 1/2 the cosine of that, 240. There's a 60. So that's square root of 3. That's 1, that's 2. And those are both negatives. Cosine of that is adjacent over hypotenuse. The sine of that negative square root of 3 over 2. You got the idea? So here it is. So here it is. The quotient. If I have RCIS theta over RCIS theta, I divide the R's and I would subtract the thetas. Go ahead, give this one a whirl. Two. CIS. Negative 210. 2. CIS 150. So far, so good?
Yep.
150 is going to be my 30. 1 square root of 3, 2. Put in my signs. 2 times the cosine of 150 is 150 plus I sine of 150. That's going to give me 2 times cosine, negative square root of 3 over 2. Plus I times the sine, 1/2. Let's see, I get negative square root of 3 plus I. Before we go any further, I need to come back to our last example. I found my mistake. Oh, this is an I. 60 minus 150 was negative 90. We had that, but this should have been 270. I think we put 240. This should have been 270. So 270 degrees is here. The cosine of 270 is 0. The sine of 270 is negative 1. So negative 1 times I is negative I. So 1/2 times negative I is negative I over 2, which matches that answer up there. I moved on too quickly. I apologize for that. But that's, these two had to be the same answer. Okay, two more, Tomas. See how I did that? See how I did that? What if I don't get something that's really nice? And I would get this guy. I want to know what the answer is in rectangular form. Now I actually have to get the calculator out. Two problems with the calculator. First one, I'm going to take 9.3 times 2.7. I multiplied those two together. I get 25.11. Now it's going to be the cosine of 125.2 degrees plus 49.8 degrees, which ends up being, how about that, 175 degrees plus I sine of 175 degrees. I'm okay with that. All right, let's see what I have. 25.11 cosine 175. I get negative 25.014 plus I times 25.11 times sine. Well, that says tan. Sine of 175 plus I 2.188. I want to make sure it makes sense. So if I'm doing this, I'm at 125 degrees, which is a little past 90, and I'm going up a length of 9, right? So my X value is, I have negative 25. What is that times the cosine of 175? I don't like my answer. Did I mess up? 25.11 times the cosine of 175. I got negative 25. Oh, this isn't 9. Thank goodness. This is 25.11. This is 25.014. And this is 2.188. So yeah, this is still bigger than this one. I need my hypotenuse to be the biggest one, folks. See where I was concerned. Chow likes this one. I don't know. I'm dividing. I can do this. 10.42 over 5.21, that's 2. This is going to become CIS of, oh boy, that number, 3 pi over 4 minus pi over 5. I think I'm going to convert these. 3 pi over 4 is what? Do we remember how to convert?
135.
I get a 135. So now I have 135 degrees minus pi over 5.
Oh, I got 36.
36 degrees. So when I subtract those, it's going to be 99 degrees. How do you do that? That's right. This is 3 pi over 4 times 180 over pi. The pi's cancel. 4 goes into that. 45. 3 times 45 was 135. Pi over 5 times that, the pi's cancel. 180 divided by 5 is 30. So I have that. So now this becomes 2 cosine of 99 degrees plus I sine of 99 degrees. 2 cosine of 99, I get negative 0.313 plus I sine of 99 degrees, 0.988. Okay, cool. Capiche? Questions? Questions? Now, that was a little bit bizarre today. The product and the quotient, and how if I'm given these things in trig form ahead of time, I know how to handle these. When am I going to use this at the grocery store? You're not. But you are going to use math, one form or another. And some of you are going on to bigger things, and this will become important.